Hello everyone. This video will cover multiplying and dividing radical expressions. Okay, so first we're going to start on the multiplying. Okay, so if you remember, let's say for example, if you have something like x squared times x plus 2. Then you just use the distributive property where you have x squared times x plus x squared times 2, which simplified gives us x to the third plus 2x squared. Okay, the same idea is used for radical expressions. Okay, so let's say, for example, you want to multiply and simplify the following expression. Okay, so if you have square root of 3 times square root of 5 minus square root of 8. Okay, so just going to rewrite that. Square root of 5 minus square root of 8. We distribute that square root of 3. Then that will give us square root of 3 times square root of 5 minus, I'll bring that down a little bit, minus square root of 3 times square root of 8. Okay, now remember, little side note here, if you have square root of a times b, you can separate those. So that's square root of a times square root of b. But you can do that the other way also. If you have square root of a times square root of b, you can put them all under the same radical symbol as long as they have the same index. Okay, so that means you can combine these two, and you can combine these two. Okay, so that will become square root of 3 times 5 minus square root of 3 times 8. Okay, so that's square root of 15 minus square root of 24. Okay, now square root of 15, you can't really bring out a perfect square, so that would stay the same. But square root of 24, you can simplify that one. And I'll put that over here out of the way. Okay, so square root of 24, remember 24 is 6 times 4. So that would equal square root of 6 times 4. So if we separate those two, that's square root of 6 times square root of 4. Square root of 4 is equal to 2, so we have square root of 6 times 2, or 2 times square root of 6. Okay, so this simplified answer will be square root of 15 minus 2 square root of 6. All right, so let's go and do another example. Move this down a little bit. There we go. All right, so let's say, for example, we want to multiply and simplify say square root of 3x minus square root of 2y times square root of 3x plus square root of 2y. Make that a little clearer. There we go. Okay, so just like you would for any other problem where you have two terms that differ just by the sign, let me rewrite this. Square root of 3x plus square root of 2y. You just use your FOIL method. Okay, so you have your first square root of 3x times square root of 3x. Okay, now you have your outer plus square root of 3x times square root of 2y. You have your inner, which is minus square root of 3x times square root of 2y. And you have your last, which is minus square root of 2y times square root of 2y. Okay, so if you look at your two middle terms, those two actually cancel each other out. Okay, so you have square root of 3x times square root of 3x. Those two, since they're both square roots, you can put them under the same root symbol. So you have the square root of 3x times 3x. These two canceled out. And here you have square root of 2y times square root of 2y. They're both square roots. So you can put them both under the same root symbol. Okay, so 3x times 3x is just 3x squared. So you have the square root of 3x squared minus the square root of 2y squared. Okay, and I wrote it this way because remember, when there's no index written down, we automatically know it's a 2. So this 2 from the exponent and the 2 from the index would cancel each other out. So if you have a 2 here, those two would cancel each other out. So that would leave us with 3x minus 2y as our simplified answer. All right, so let's do another example. Oops, slide this down. Okay, so let's say, for example, we wanted to multiply and simplify. Let's say negative 3 times the cube root of 10y to the third power. Let's say that is raised to the third power. Okay, so with this one, you remember the power of a product rule is that a times b to the nth power equals a to the nth power times b to the nth power. So that means this exponent of 3 on the outside is going to be distributed to both of those factors. Okay, so you have negative 3 times the cube root of 10y to the third, and that raised to the third power is just going to equal negative 3 to the third power times the cube root of 10y to the third power to the third power. Okay. Now, negative 3 to the third power is just negative 3 times negative 3 times negative 3, which is negative 27. Now, with this one, you just have to look at one thing. if you notice, your index matches your exponent. So you could cancel those two out. Or if you wanted to, you could have separated these two and then distribute the exponent, but you would have ended up with the same thing. Okay, so when those two cancel out, you're left with whatever the radicand is. So it's times 10 times y to the third power. All right, so right now we're just going to go ahead and combine those two. Negative 27 times 10 is negative 270 times y to the third power. Okay, so as you see, the same rules for multiplication apply as they would if you use regular variables. All right. So now we're going to look at simplifying radical expressions, but division. Okay, so dividing radical expressions. Okay, and that comes from rationalizing the denominator. Okay, now rationalizing the denominator, the simple way of explaining that is you're just going to remove all radical symbols from the denominator. Okay, now there are a few things I want to point out before we get started. Okay, so you want to notice if we have square root of 2, or better yet, let's say square root of 7 times square root of 7. Okay, if we put those both under the same radical symbol, that's square root of 7 times 7, which is square root of 49, which is positive or negative 7, but for what we're doing, we're just going to look at the positive value. All right. The thing is, that would work with any square root. Okay, so let's say if you had square root of 6 times square root of 6. That would equal the square root of 6 times 6, which would be square root of 36. Usually plus or minus 6, but we're just going to look at the positive value for right now. Okay, now what if we had a cube root value? So let's say we had the cube root of 4 times the cube root of 4 times the cube root of 4. Okay, they all have the same index, so we can just combine them under the same root symbol. So we have the cube root of 4 times 4 times 4. Okay, so if you notice, that's the cube root of 4 to the third power. So your exponent and index cancel each other out, and that will be 4. What if we had the fourth root of 3? Shorten that up a little. instead of 3, don't have, let's say the fourth root of 8, just to kind of mix it up a little bit. Okay, so if we have the fourth root of 8 times the fourth root of 8 times the fourth root of 8 times the fourth root of 8, notice that's just equal to the fourth root, if we put them all under the same symbol, of 8 times 8 times 8 times 8. Okay, which means we could rewrite that as the fourth root of 8 to the fourth power, since that's just 8 times 8 times 8 times 8. And here, our exponent and index cancel each other out, so we're just equal to 8. Okay, hopefully you're noticing the pattern, because if you notice here, square root, remember, that's when there's no index there, that's assumed to be a 2. So that means it would take two values of 7 multiplied, well, 7 times 7, to cancel out and equal 7. Same thing here. 6 times 6 will cancel out and give you 6. Same thing here. 4 times 4 times 4 will cancel out with the index and leave you with 4. Here, 8 times 8 times 8 times 8 will cancel out with the index and leave you with 8. So if the number of values or the number of radicands you're multiplying is equal to the index, they will actually cancel out with the index and the exponent. All right, so let's apply that to our example. Okay, so for example, what if we wanted to simplify say 5 over the cube root of 6n squared? All right, so the first thing we want to do is we want to look at that index, because we want to get rid of this root symbol at the bottom, that radical symbol at the bottom, that cube root symbol. We want to get rid of that. So if we remember, before we even get started, that if we multiply the cube root of 6n squared 3 times, it'll get rid of that root symbol. Okay, so you have the cube root of 6n squared times the cube root of 6n squared times the cube root of 6n squared. That's going to equal 6n squared. So that means, starting from where we are now, if we have 5 over the cube root of 6n squared, we're just going to have to multiply that by the cube root of 6n squared times the cube root of 6n squared over the cube root of 6n squared times the cube root of 6n squared. Okay. So if you notice, all we did was multiply 2 more cube root of 6n squared, because this way all 3 of those would just cancel out and leave us with 6n squared. Okay, so we know our denominator is just going to be 6n squared, because all 3 of those canceled out. Okay, so that leaves us with our numerator of 5 times the cube root of 6n squared times the cube root of 6n squared. Okay, now since both of these have the same index, we can go ahead and combine them. So that's just going to equal 5 times the cube root of 6n squared times 6n squared, all over 6n squared. Now remember, you can't cancel these out because cube root of 6n squared is not the same as 6n squared. So you can't cancel any of those out. Okay, so if we go ahead and combine those, we have 5 times the cube root. 6 times 6 is 36. N squared times n squared is n to the 4th power, all over 6n squared. Okay, so actually what we could do is we could kind of separate these, because n to the 4th power is equal to n to the 3rd power times n, or n to the 1st, whichever way you want to say it. I'll put the 1 right there, but the 1 really isn't necessary. Okay, so if we go ahead and separate that, we will have 5 times the cube root of 36 times, and instead of the cube root of n to the 4th, we'll have the cube root of n to the 3rd times the cube root of n. So all we did was get our n to the 4th and break it down to a cube root, or cube exponent, and another exponent of 1. Okay, and that's all over 6n squared. Okay, now if you notice here, the exponent and index cancel each other out. All right, so that's going to equal, you have 5. Since the index and exponent cancel each other out, that's just n. Okay, so 5 times n times cube root of 36 times cube root of n, all over 6n squared. All right. So now if you look closely, this n cancels out with one of those n's, because n squared is just n times n. So this cancels out with one of those n's there, which leaves us with 5. That n is already canceled out. So you have cube root of 36 times cube root of n, all over 6n. The only thing left that you can do really is just combine those two. So you have 5 times the cube root of 36n, all over 6n. All right. So once again, all you're doing is you're getting all of the radicals out of the denominator, and you're simplifying it after that. Okay, so that's if you have just one term in your denominator. Okay, what if you have 2 terms in your denominator? Okay, we'll go ahead and handle that example now. All right, so let's say, for example, if we wanted to rationalize the denominator, okay, so if you have square root of x plus square root of 2 over square root of x minus square root of 2. Now the thing about this is, you may see the question say divide this, you may see it say rationalize the denominator, you may see it say simplify. All of those are just the same thing. Okay, when you see a division problem, whether it says divide, rationalize the denominator, it all means remove any and all radical symbols from the denominator. Okay, so when you have 2 terms, you want to multiply Let me write that down. When you have two terms in the denominator, multiply both by the conjugate of the denominator. Okay. Now the conjugate of the denominator is just changing the sign. Okay, so square root of x minus square root of 2 has a conjugate of square root of x plus square root of 2. That's it. Conjugate is just a fancy way of saying change the sign. Alright, so we're going to start off with here, and we're going to go step by step on how to solve it when you have two terms in your denominator. Okay, so if we start off with our square root of x plus square root of 2 over square root of x minus square root of 2, first thing we're going to do, square root of x minus square root of 2, is we're going to multiply it. First put our parentheses there. So we have square root of x plus square root of 2 and square root of x plus square root of 2. Okay, so whatever the sign is for this denominator, you're going to put the exact same terms, but just change the sign. That's all. Okay, so when we do that, now we're going to FOIL these two. Okay, so square root of x times square root of x. That's your first. You have your outer, which is square root of x times square root of 2. Then you have your inner, square root of x times square root of 2. Then you have your last, square root of 2 times square root of 2. Okay, so that's over. Do the same thing, FOIL down here, square root of x times square root of x. Okay, now you have your outer, which is square root of x times square root of 2. You have your inner, square root of x minus square root of 2, so that would be minus square root of x times square root of 2. Then you have your last, which is minus square root of 2 times square root of 2. Okay, so if you notice, whenever you multiply by the conjugate, those two will cancel each other out. All right. So we look at our numerator and we start to simplify each term. Okay, square root of x times square root of x, we can put those under 1. So we have square root of x squared plus square root of x times square root of 2. We can just put those under the same. So square root of 2x. Same thing here, square root of x times square root of 2 plus square root of 2x. And that's plus square root of 2 times 2. All over, you have square root of x times square root of x, which is, again, square root of x squared. Those two canceled out, so that's minus square root of 2 times 2. Now, of course, if you wanted, you could have jumped right ahead and gone to square root of 4 and square root of 4. I'm just doing the step by step to make sure that no one's confused. All right, so now, if you notice here, when there's no index, it's automatically assumed to be a 2. So the exponent cancels out with the index, so that leaves you with x. And these two, since you have square root of 2x and square root of 2x, you can add them together because they're exactly the same. So if you have x plus x, that would give you 2x. So this one, square root of 2x plus square root of 2x, is plus 2 square root of 2x. Okay. So plus square root of 2 times 2 is square root of 4. So we know right here, square root of 4 is equal to 2. And same thing down here since we're going to have that. So we have 2 here. All over here, same thing when there's no index. It's assumed to be a 2. So those two cancel out. That just leaves you with x minus square root of 4, which is 2. So x minus 2. Okay. Now this one can't be simplified anymore. So this is now your final answer. Alright, so let's go to another example. Okay, so let's say, for example, we want to simplify. Remember, it could say rationalize the denominator, simplify, divide. It's all the same thing. Say 4 over the cube root of 2. Alright, so what I want you to do is press pause and work on this one yourself. Alright, so assuming you've pressed pause and worked this one out. Of course, first thing you want to do is look at your index. Okay, so that means you have to multiply cube root of 2 3 times in order to cancel it out. So cube root of 2 times the cube root of 2 times the cube root of 2 will equal 2. Okay, so if we want to go ahead and get rid of the root symbol in the denominator, we have 4 over cube root of 2. Let me straighten that up a little bit. Okay, we have to multiply our denominator by cube root of 2 times cube root of 2. And we have to do the same thing to our numerator. So times cube root of 2 times cube root of 2. Okay, so we know that cube root of 2 times cube root of 2 times cube root of 2, say that 5 times fast, is equal to 2. Okay, so here we have 4 times cube root of 2 times cube root of 2. We can go ahead and combine those. Okay, so we have cube root of 2 times 2. Okay, now you can simplify those two. Okay, because they're factors. Okay, you can't simplify the 2 with either one of those because it's under the cube root symbol. But you can simplify the 2 and the 4. So 2 goes into 2 one time. 2 goes into 4 twice. So we're left with 2 cube root of 2 times 2, which is 4, over 1, or just 2 cube root of 4. Okay, so remember, you can't simplify this one because you can't really think of a value that you can multiply to itself 3 times that will give you 4. So it stays cube root of 4. right, so let's do another example. Say you want to rationalize the denominator of, say, square root of x over square root of x minus 3. Okay, remember, now you have two terms. Okay, so what I want you to do is go ahead and press pause, and I want you to work on this one using the same steps that we used on the other example that we had two terms in the denominator. Alright, so assuming you have already pressed pause and worked this one out. Okay, so with this one, you have two terms. Okay, so you know square root of x minus 3 has a conjugate of square root of x plus 3. Because remember, you're just changing the sign. Okay, so that means the problem we start with, square root of x over square root of x minus 3. That's going to equal square root of x over square root of x minus 3. Go ahead and put that in parentheses. Times square root of x plus 3 over square root of x plus 3. Okay, now down here, you're going to use the FOIL method. But up here, you're just going to distribute. Okay, so if we go ahead and multiply those, you have square root of x times square root of x plus square root of x times 3, or just 3 square root of x. Okay, so we went ahead and we distributed the square root of x in our numerator. So now in our denominator, we go ahead and use the FOIL method. So we have square root of x times square root of x for our first. Square root of x times square root of x. Okay, then you have your outer 3 times square root of x. So plus 3 times square root of x. Then you have your inner minus 3 times square root of x. Then you have your last minus 3 times 3. And again, if you want to just put 9, you could. I'm just going through the steps here. So here, you notice the two middle terms cancel each other out. Okay, so you have square root of x times square root of x is just square root of x times x plus 3 square root of x all over square root of x times square root of x. Again, is square root of x times x. Those two canceled out, and minus 9. Okay, so here, remember square root of x times x is just square root of x squared, which is just x. Remember that when there's no index, it's a 2, so those two would cancel out, leaving just x. So this is going to equal x plus 3 square root of x over x minus 9. Okay, and that would be your simplified answer, or your rationalized denominator. Okay, so hopefully this video made sense. I will see you on the next video.